I'll try. Oh, hi there. Danielle Awan with Yokogawa. Sorry about the lateness. It was some technical issues, but we have them sorted out. So today I'd like to live stream about the Optical Spectrum Analyzer, or OSA for short. Specifically, we'll be talking about the AQ6370D and maybe the AQ6380. So I'd like to just kind of go over a brief outline of what I'm going to say during this live stream. So I'll like to explain what an OSA is, what a grading-based OSA is, the optical wavelength calibration of our devices, and maybe some demonstrations, and then open the floor to some questions. So first things first, what is an OSA, an optical spectrum analyzer? So it's an instrument designed to measure the distribution of optical power over a specified wavelength. So it's just kind of measuring the optical spectra of a source. And that includes some applications where you're measuring maybe an LED or a laser or some type of light source. It's not always limited to an optical, it's not always limited to the visible spectrum. We also have different types of spectrums it can do. So it can do O band or C band. The C band is essentially a section of the optical wavelength where it hits between 1530 nanometers and 1565 nanometers. That is just called a C band. If our engineers are measuring those type of wavelengths, then we'll be able to do that as well. So I'm just going to take it to my computer. There's some diagrams I'd like to show. So if you could just hold on 1 second. So we're going to go here. And so I'll be kind of in the corner right here. And I have a nice little PowerPoint going. So as I said before, optical spectrum analyzers, I mentioned a grading-based optical spectrum analyzer and also an interferometer based. So what is happening is a diffraction grading based OSA is essentially uses a motor to move a grating, and that is how it measures the wavelengths. And I'll get more into it very much so in the next slide, but now I just want to introduce that there is a grading based and interferometer based. It is more along the lines of using a series of mirrors. That's a very simple term, but more mirrors to kind of capture those different wavelengths. So they're using different types of ways to kind of split a light source so that it is measuring certain wavelengths. So as we can see here for the block diagram, we can see that light goes into an optical bandpass filter, then goes into a photodiode that is reading that light, and then that signal is amplified, going into an A to D converter, and then is displayed. So I have a little display here. It's a little hard to see, but that display with the blue markings is a reading from one of our OSAs. And then we also, it goes from a ramp generator, and that ramp generator, in other words, is a combination of either the ear mirrors from the interferometer or it's from the grating. So going on. So just to kind of jump into details for that grating, we can see that it's a combination of the bandpass filter and the ramp generator from the previous diagram, and just moving into more detail of that grading, we can see that in the top leftish corner of that mostly purple diagram, we can see that an optical signal is going into the OSA. In this instance, it's just white light. It is being hit into a collimated mirror, which essentially focuses and reflects that light, and that light is given onto a grating. And that grating, in other words, is just like a very special mirror where you can split light. So it's kind of like a prism. So this mirror of prisms splits the light, then it hits another mirror, and all those colors, those split colors, are then kind of directed toward an optical slit. And that slit, depending on where you are exactly measuring, moves around or widens and kind of retracts, gets smaller to read exactly what that optical signal is. So, just moving on, I'd like to show an optical alignment, just some demonstrations with our AQ6370D. So I have this live, so let me do this. There we go. So right now this is our AQ6370D. I have not really, I don't have it set up in a way that I kind of wanted to show what is going on. So right now we have a optical cleaner right here, and then we have an optical fiber. And just a good rule of thumb is that you want to clean these fibers before putting them into the OSA. It will not damage it, but it's a good rule of thumb just to make sure that your measurements are accurate. So just want to open this, clean them, then insert it correctly where the keys and key slots align. This. Where's the key? Oh, there it is. So make sure those are aligned. There we go. So, and you also don't want to tie them too tight, but just insecurely. So, perfect. It is ready to go. So before testing, another rule of thumb is you kind of want to do an optical alignment. So let's see, let us do setting, and sorry, you would hit the system soft key and hit optical alignment. And then it's going to choose execute, so I obviously want to do that, and it will start measuring. So it'll take a little bit of time to do that. And just like some little side tips as well. If the I get some questions sometimes saying, oh no, it failed. Why is that? That's not good. So in this instance, the optical alignment failed. Usually this is because that maybe the fiber is dirty, maybe I didn't clean it enough. Is it in properly? Let me see. So let me check and see if I did this properly. And it's funny, like I tested before and it passed, and of course when I'm doing this it fails. So Just checking, making sure. Alright. Let's see if I can. Checking those. Alright. Let me see if I can get it working. Usually this doesn't happen, but life happens. So maybe. Oh, and as I was saying before, it was finished. General rule of thumb with these is that you do want to do an optical alignment before you're testing, just to make sure that your measurements are on key. You don't have to. Oh, that's that's wonderful. We are just going to go ahead then, and let me see. So instead, let me do a sweep and see if the notch, or I'm sorry, where it is measuring is correct. Maybe we could see something there. So it's zeroing. When it's zeroing, you can't really do anything. So let's just do a quick auto sweep. So the auto is working, and it is not really going. Nice. Let me see if there's something I can do. One moment. All right. Sorry for the problem right now. So warning 109 tells me that the light is not sufficient. So let me make sure. I'm hoping it's not the fibers, but let me just change these out instead. Let's try this instead. So just make sure that we clean these before. Line up the key slots and let's do here. Alright, so let us try. Let's try this one more time with a different fiber. Just wait a little bit and see. All right, this is pretty new, I have to say. For some reason, it is not going. goodness. Let us see. So instead, let me try this bad boy out. This is our 6380, one of our newer models. Let me see if he will work instead. I'm curious as to know. Nope. Alright. That one, the 6380 is still going. Let me try this instead. So both are failing right now. Not my best of points. Strange occurrence has happened. Tried 2 fibers. So I'd like to just move on to the 6380 instead and see if that one will treat me any better. So let me just change screens if you don't mind. Let me just do this so I can see properly. Then exit that. Alright, so then let me try this. Let me change wires real fast. So let me bring it up. Let's do that and then both are failing. Just 1 second. Let me see if I can get reading from here to here. Yeah, just like to troubleshoot this problem. Alright, so I can get a reading on the 6380, so I will show that. Let me get it right. Ah, goodness. There. So right now, the 6380 did calibrate properly, and I decided to put a, let's see, a 1310 signal going into it, just so we have something to see. This is from an AQ6270, which is just a laser output. So right now, just like to show that we do have a signal going through. let me show the auto. So suppose if you can hit sweep, or I'm already there, so you can hit sweep and then auto, and that will automatically find the peaks within that range. So it comes up with the same thing, and there we go. So it's a little shaky on the remote viewer that I'm using, but that will do instead. So then there are some other features I'd like to show off while I'm here. So we can let's do a peak search. So our peak search function essentially finds the highest peaks and marks them for you. So as we can see here, I have just done a peak search, and it's finding a peak at 1304.98 nanometers. Good stuff. Suppose if we want another marker. So let us just, oh, it's zeroing. So let me do set marker. Let's set it as our first marker so we don't forget it. And then let us go to, let's see, let's search right and see if we can find another marker. So here's another peak that it is finding, and let's set a marker there. So that will be set marker 2. And of course, so on and so forth. Let's go back to the left. Set marker, we can set that as 3. And then, boom. We have some markers. Just if you want to read some markers or peaks that have been on your OSA for whatever reason. If you're trying to figure out the peaks or find out what's happening, you can always set markers to help out. We also have analysis. Let me see. So for analysis, you would hit the analysis button, and let's just do a WDM analysis. So our WDM analysis is another feature we have on plenty of our OSAs on the AQ6370D or even the AQ6380. Our other models also included. But what we are seeing here is that the OSA is detecting those peaks that are given to us by that 1310 laser, and we are seeing all those peaks named up and different properties of it. So to the bottom, we can see that it is finding peaks at 1301, 1302, 1303, and so on and so forth. And of course, this OSA is still sweeping while it is reading this. So these are live results. We can see the level, we can see offset wavelengths, offset levels, some noise if that is an issue, and the SNR, which is signal to noise ratio. So just one feature. Of course, we have other features. I don't have an active trace for there, so we can do, let us do SMSR. So that's side mode suppression ratio. Just a kind of comparing two peaks to each other right there. And we can see that it is finding one peak at 1, a second peak at 2, and just comparing the side mode suppression ratio of the two. And we can see it even compares like how many nanometers are between those peaks. So we can see that it's about 0.8 nanometer different. And when it calculates that SMSR, it's 1.18 dB. So we just have a lot of good things. We have a general power if you need to measure power, and it's measuring the power at negative 0.77 dBm. We have some also just general DFB LD analysis, which is peak wavelengths, mode offsets, peak levels, center wavelengths, power, of course, all that good stuff. So I think that I showed off quite a few of these pretty well. And then let's see. So of course, another question that kind of generally comes up sometimes is how can I save this and how can I transfer it from an OSA to a PC, for example. So we can go to File, Soft Key, and that comes up with save, load, etc. And we want to load. Oh, I'm sorry, we want to save. Whew. So it can kind of give a general description of what it looks like. It's showing the traces that it detects, and we want to save it. It can save as binary or CSV. This is the third file on this particular OSA, but we can just hit save right there. And I saved a lot more, but as you can see, it saved just extras. And then you can quickly just load a file, choose what you'd like. So 1, 2, or 3, we know what each of them are, and yeah, just comes up with what you had on it. You can choose to save as a trace or even graphics, meaning if you want to save a picture, so it'll save like exactly what you see on the screen as a PN, or is it? Yeah, it'll just save it as a bitmap picture for you to access later. So if you want to save onto a USB instead, you could always let me see. You can always choose where you'd like to save. Right now it's showing that it's saved as PNG, bitmap, JPEG. You can save it as black or white, just different colors for your need. And if I had a USB, you could also save it onto the external. Right now it's into the internal, but if it had an external, you would be able to easily see it would come in this drop down. And even just a shortcut if you're wanting to save settings in case you need to update the firmware or data, anything of the like. So you can do many things with our OSAs. And another key feature that I wouldn't be able to show off on the AQ6370D would be the app feature. And what this essentially does is kind of shortcut some tests that you'd like to do. It's a new feature that we're trying to release more apps for, but you have, as I showed off before, DFB LD lasers test, or fiber scope inspections, or just shortcutting LED tests. So if we just went quickly to the WDM test that I offered before, you can just click that, and then it should. And then we're going to hit on. And it's just sweeping around. And apparently it takes a little longer than I'd like it to. So as we can see from before, it's done. it's pretty similar to what we saw before. We see the wavelengths, we see the levels, we see the offset wavelengths, offset levels, we see the peaks, we see exactly what we saw before, maybe in a different design, but pretty similar, and it senses what you would exactly on the WDM testing. So of course, you can even save this for later use if you'd like. Of course, this is to the internal, and I want to save it as a trace, so it would save as 6 if I decided to. Just very easy things. And to exit out of the app, you just hit the little X in the top and close the app. So it does run separately from your actual main screen OSA. We are trying to add a few more apps to it, but that would be a future thing. And yes, I'd like to open the floor to some questions as well. Sorry if this isn't what you were expecting. Let me see. So, can the OSA measure pulse light? Yes, it can. It does have a limit to how fast it can go and how high the OSA can handle the amount of light. I will say that it is within the nanosecond range of pulse light, whether it can handle that or not. Or I'm sorry, it can handle a nanosecond, but I would need to link you the app note. We do have an app note specifically on that. Alright, and then another question is, I understand other parameters or functions the OSA can offer. Does show constellation diagrams of modulated optical signals. So let me get that. So let me, sorry, I'm just trying to low-key troubleshoot that other OSA. And sorry, to answer that quick chat, it does say it does show constellation diagrams of modulated optical signals. That was your question. No, it does not, unfortunately. And sorry, I have opened the floor to questions, so if you have a question, you can post it in the chat. Let me see. Any more? And of course, I didn't show off all the analysis, but we do have a total of 13 built-in analysis routines, and of course that could be found under analysis, and just going through each one, kind of just going through them real fast. But essentially, yes, we do have 13 built-in analysis, just for note. waiting to see if anything else comes up. OSA stands for Optical Spectrum Analyzer. And how often should an OSA be calibrated? So typically before a test you want to do the internal calibration. That is just a general rule of thumb. And then for actual, like, when that calibration fails, you'd want to send it in for, let's say, NIST calibration, where they test different wavelengths instead of just one wavelength that the internal calibration does. And that will essentially put your OSA back into calibration, since there is a limit of what the internal calibration can do. And then primary use for the optical spectrum analyzer. So you're just trying to find the optical power over a specified wavelength. Of course, you can do analysis with our OSAs as well. Signal analysis? Fios. Fios signal analysis, if I'm looking here. Oh, it's calibrating. Let me see. So primary use for so if you're asking if it does Fios signal analysis, not to my knowledge, but possibly if that optical signal requires a wavelength measurement. And if there's anything else, I don't want to like cut it off too soon, but let me see. So generally what our OSAs, just like as another side note, our OSAs are fiber based. So if you have a signal that isn't fiber based, we do have a workaround we can do that will allow you to essentially put light that is not into a fiber, essentially a free measurement jig setup is what it's called. And what it'll do is take some free space light, directed into a fiber, and then that fiber can go into an OSA. And then the wave source we are using continuous wave source of a 1310 nanometer source, and you can also change it. Let me see. Oh, I don't think it is sweeping. Oh. There we go. Just to have something changing. So with this device, I can also change the hertz it is going at. So let's change it to 1K instead. So just something different, of course. And zeroing. And of course, if the zeroing also gets a little too annoying, just hitting the auto offset button at the very bottom right here essentially turn that function off, so it shouldn't zero anymore. Let me just change it back to continuous wavelength. Oh, I'm sorry. And to properly say what light source it is, it's a FBLD light source. Oh, so there is a way to virtual demo. As seen with this, we can use a remote viewer as well. On our website, it is called the AQViewer, or depending on what product you have. We also recently came out with OSA viewer, this little window right here. And what that allows you to do is you can remote monitor, remote control, or even file transfer between the OSA and the computer. So when I mentioned before how to file transfer, you would use this program to transfer files. Otherwise, you can of course use a USB, save it to the USB, and then put it onto your computer. And this covers a broad range of different OSAs. I don't really want to change it because right now I'm connected. But you can do the AQ6370, of course, and by model, we have different iterations of different series. So I would choose the 70D, so we can just change it. Yeah, so we can change it between 70D or 70C. And then what calibration do you offer for your instruments? So we offer NIST calibrations. We can do that in Noonan, Georgia. United States. And then we do offer production versions of OSAs. A very good example would be a 6360. I'm sorry, an AQ6360. But we do understand that sometimes the customer does not need buttons, or they do not need a viewing screen, a monitor, and there are options to get OSAs without that. want to try changing it to 1550. So I've just changed the wavelength to 1550 instead, and of course it's going to zero out those. So let me just do an auto sweep. Alright, nice. So we changed it, and we can see that it is within that 1550-ish range that they are now detecting. And of course, a big feature I would say with our 6380 is that it can reach resolutions of 5 picometers. So if we just change it here, we can see that the 5 picometers is right there. And then we get some nice fine lines. And then any future plans to release an OSA that measures in the L band. So I will say that we do have OSAs that can measure the L band. They will have a lower resolution than the AQ6380. If I'm not mistaken, it would be around instead I would say 20 picometer range, so about 0.02 range instead. I'm just giving an example. I'm very used to being hands-on with these devices. And then of course, sensitivity, we have some new options. Let me change it to something. Very nice. And the sensitivity option, of course, you're kind of a give and take with the sweep speed. As you can see, with increasing the sensitivity, I have essentially decreased that sweep speed. So it takes quite a few seconds more to complete. It's a give and trade. So it can do very high sensitivities, but at a slower sweep speed. So if you are on a time limit, it would be better to go with lower sensitivities. Beautiful. Then if we go, we also have rapid, and the choices of these rapid sensitivities is essentially to increase those sweep speeds while still trying to keep that some, I wouldn't say noiseless, but less noisy readings. So we can do, and of course we can go faster, but as you can see, the noise does increase quite a bit. We do not sell Ando OSAs, not anymore. We bought Ando quite some time ago. We still support them, such as the AQ6315 or the AQ6370. We still do support them. But unfortunately, what tends to happen with those models is that either the display goes or the buttons don't work anymore. In those situations, at least if the display goes, it's better to just hook up an external display. With the buttons, there's not much we can do to actually repair the unit at this point. The parts for it are long discontinued. change this back to a rapid 6. Yeah. So nothing quite as noisy. And then of course we have normal, a little noisy there, and then normal times 2. So it's essentially normal but a faster sweep speed, and as you can see, pretty good, pretty fast. And then we even high times 2, so let's see. So it's going faster than high 1, but it still takes quite a bit of time, a few seconds less. How long does it take to send in an OSA for calibration and have it shipped back? Currently, I don't know if there's any delays or so, but I would guess around maybe 2 to 3 weeks. Let me see. So, showed off those sensitivities. We can of course average more than once if you'd like, up to 999 times. We also have sampling. It's on auto right now, so it's taking 5001 samples. If you choose, you can also decide how many samples you want to take. Depends on how much data you want. Let me see. Span, of course, changes essentially how much of the wavelength you are seeing. So right now it's at a 1550 reading. If we decide to change the span to maybe, let's do, so it gives a little quick warning, but as we can see, the laser tries its best to give that 1550 angle and then kind of tethers off towards the end. But this is essentially just the reading widened so we can see more of what it's, more of the wavelength range. So before it was in 1500s, or I'm sorry, 1550s, pretty close, give or take plus or minus 10 nanometers. Right now I've set it so that it's going plus or minus 50. So, can I remote control the OSA? As I mentioned before, the OSA viewer right here allows you to remote control right at this option. I don't really want to click it right now because it's set for the 70, which I am not connected to anymore, and the 80 I'm already connected to. And yeah, that is pretty much the live stream. If we have any more questions, I'm down. If we do not, then I would say it was a good run. I'm sorry for the troubles we had with the OSA and starting up the stream. I think it turned out pretty good. Fernando, do you have any more questions you'd like to ask? Oh, well, it looks like that is it. Let me change it so... what? Okay. Yeah, I'm still here. Thank you so much for watching and for your chats and comments and questions.